Good morning.
Good morning.
To you and you. Okay, anyway, you guys need to watch The Sound of Music. All right, anyway, all right, so we kind of left off on this yesterday's. Okay, and all right, so right here, let's take a look at this. See this right here? Yeah, that's the W, right? That's the width of my rectangle. But now we're just commonly referring to it as delta x, where delta is a mathematical term that is symbolized by a triangle. Yeah, that's what that triangle right there means, delta. Ooh, you know it's Greek? Yeah, did you know that? Yeah. Ooh, all right, so delta x. So that means it's the change in x. So it's the difference in x. I know, right? Dang. Oh. Man, yeah, superseded. Anyway, all right. Yeah. It's basically this. Now, when we actually do the sum of the parts, so what we just did is the sum of how many parts? No, that last one that we just did. There was 4 parts, right? Yes. So yes, there was 4. Yes. Okay, thank you. There was 4 parts, so we did the sum of those 4 parts. But now, what if we take delta x and break it into an infinite number of parts? An infinite number of parts. Okay, that's what we're thinking about now. So instead of actually, having the whole thing, we have a bunch of tiny. So we went from having like whole numbers as my W, so now we're actually having fractions. Like tiny, minuscule fractions, okay? And as we're doing this, as we're taking the sum of these, we're getting closer and closer to the actual answer. When we were taking limits, and we were actually coming up to some number, right? We're getting to that some number. It's never really going to get to that number, but as you take it to infinity, we can mathematically show that this is now going to be this. Okay, it gets so small, we're divided into infinite number of parts that my number is so close to 0 that it's now going to be 0, right? Those type of things with the limit. But in this case right here, it's getting infinite number of parts to find my area. So I'm going to go back to the question we were working on. We're going to have infinite number of parts. So right now I did a left hand, which is 35 over 4. My right hand was 37 over 4. Okay, what do you think what would happen if I go to, let's say, 4 parts? What do you think if I went 8 parts? It would be closer and closer to what? Looks like 36 over 4, which would be 9. Okay, so that's kind of what we're doing here. So it would be 9. It's coming, so from the top end, the underestimate that you started with, right? And then we have the blue, which we did the right hand. So it's the overestimate. So as I get the unders and over going back and forth and averaging them out, I'm eventually going to find something in between there, right? That's what I'm getting to. I'm trying to get to that with the infinite number of parts. And that's what we're doing. So now, this is basically, this is something we do in BC. I don't want to kill you guys with this. It's really not bad. It's not bad, but the introduction to this should not be right now. So it's basically, this is my speech I'm doing for this whole thing, and we'll talk about it here in a second. So, I'm going to go, okay, like this. For n being any number, okay, sum of rectangles extended above the graph, okay, for this one, what shape is that? It's a triangle. Do I need to kill myself on the calculus for this? No. What's the actual area supposed to be?
Like 150.
150?
Yes.
So it is, the area would be 1/2, right? 10, which is my base, times my height, which is 30, which would give me my area is 150 units squared. That's the exact area, right? But we're using calculus, and since this is a straight line, it's really not bad trying to get this. But calculus is made to actually do stuff with curves. Okay, straight lines, you just see geometrical shapes and you're like, hey, dang, I got this, it's good. Okay, but when we start getting to the curves, you actually have to use the calculus to get that, to estimate the curvy part of those. So for this, if I were to break it into different parts, let's see. So if I start off with number of rectangles being, let's say, I'm going to break it up into twos. A left hand and right hand. I know I'm doing it wrong right now, but I'm trying to show you something. There you go. So, let's see. Block that off, block that, block that, block that, block that. And then there. Something like that. So when I get my overestimates and my underestimates all through there, I should be getting over 150 and under 150, right? So let's start with the under. The under, what is my W right here? What's the width, or my delta X? 2. Delta X, the change, right? So it's going to be 2 here. So it's going to be 2 times, let's do left hand, so this is going to be 0. So that's going to be a 0. Okay, left hand, so this is again 2, but now at 2, that gives me what? 6. So 2 times 6 is 12. 2 times 12 is, yeah, it's 24, right? And then 2 times, and because 6 is going in here, this is going to be 18, right? 2 times 18 is? Okay, and then again, it's right here, so it's 24 times 2. So if I were to add all those together, that should be an underestimate below 150, right? Say yes. Okay, and now let's try the blue one. We don't actually need a number on it. I'm just using this as examples. All right, so if we go for the blue one, that means that this one right here is going to be 12 because I'm now doing the right hand of this. So the right side, so at this point it's going to be 12. This one's 24. This one's 36. This one's 48. And now my last one, which is a right hand estimate, so it's going to be 10 times 3, which is 30, right? 30 times 2 is 60. Yes. Yeah, go ahead. So all that blue should be a overestimate. So it should be over 150. So we're eventually trying to get from our estimating to an exact. Using the sum, finding a limit of this, we will do that. And I will show you using the question we had, number 5. So number 5 from the homework said f of x was 1/2 x, was it plus 3?
Yes.
Okay, plus 3. Now, we're going to do the antiderivative here. So, and this actually gets into something we're doing next unit too. So I'm going to introduce it now because it makes sense now. So now, this is how an integral is written, which that's an antiderivative. So we're taking an integral from, what was my bounds on this one? 2 to 4, right? 2 to 4, and my function is going to be 1/2 x plus 3. And now, we took the limit, the infinite number of parts, right? The infinite number of parts. And that's going to be my delta x, right? It's whatever the thickness is of those parts. But we took those parts all the way to infinity, right? So this is going to be, yeah, delta x, so dx. Just so you know, that's a dx, which is the delta, it's lowercase delta in Greek. You could actually just write delta x with the triangle too, but dx is, yeah, that's a weird s. That's the integral symbol. It's a big little curvy s. Or anyone in band? What's that thing called in band where you start with that big?
Bass clef.
Yeah, that thing, bass clef. Huh? Treble clef.
You said like that. That's the bass clef.
That!
Oh, it doesn't look like that.
He's talking about trouble.
Because he said that.
Like that. What's that?
That's not. Oh wait, if you
keep
take
going.
the
Yeah,
no, if you
it's
take the curve out, hold up, take the bottom curve out, and then you make it the other way. If you inverse it's just like.
Okay, anyway, it looks like some musical note. I have a calculus book that has the symbol and it has music on it. But it's, you know, wow. Good thing I'm recording this too. Oh, man. Okay, so I'm going to do the antiderivative of this now. So this is going to turn into
2x squared. I mean x squared. Sorry.
x squared, right? Because it's going to be, watch, it's going to be x squared, right? So I would do the variable first. So x squared, so I add 1 to the variable, right?
Yeah.
But where does that variable go now?
Divide.
Divide. And so it's going to turn into over 4. Very good. Over 4. Right? Now, then it's going to be plus 3x. And since we are doing a definite integral, that's from point to point, I'm going to use these. So watch this. Watch this. There. All it is I'm moving my interval. So it shows the interval of where it goes.
Where did D go?
Huh?
Where did D go?
D is the delta x. It's the area. Okay? It's the area of this. So it's actually, when I do the antiderivative, it's actually incorporated into this from my here. Okay? So that's what we're doing. Remember, antiderivative is going to give me, you know, the area under the curve. Where delta x is going to be the thickness of this. Okay? So after I do my derivative or my integral, that's actually already part of this from here. Okay? It's part of my math.
How come it turned into a straight line instead of letters?
Okay, because this is now the bounds over here. Okay, because I already did the integral, and now it's my bounds. I did the integral, and these are my bounds. Okay? So, weird symbols, stuff that you've never seen before. Now, watch this. So now, this is what we're doing. We're going to plug in top minus bottom. So it's going to be x, top minus bottom. So it's going to be 4 closed squared over 4 plus 3 times 4. And when I do my integral, you know what? I'll show you this right now because it'll make sense right here. Remember my plus c? Okay, there's always plus c, right? And I'll show you why I didn't write it up there. You'll see why in a second, okay? So, minus my bottom, which is going to be 2 squared over 4 plus 3 times 2 plus c. like I said, there is some madness to my method. So this is all something new that we're actually, I like introducing it and talking about it now, even though this is not the point to actually start doing this. This is the point to talk about it. And next unit, we're going to get into it more of actually doing it. Okay? So we're just talking about the area and telling you why things are where they're at. So from here, let's go ahead. So 4 squared is 16. Divided by 4 is 4 plus 12. What do we got? 16, right? So it's 16 plus C. Okay, so it's going to be 4, right? Over 4, which is 1, right? Plus, okay, which is going to be 7 plus C. Distribute. Distribute. The C's cancel. There we go. That's what I was getting at. Because I'm adding it to the left side and I'm subtracting it from the right side. Okay? That's why I didn't put it up here, because the C's are going to go away no matter what. Because whatever constant I have here, I'm adding the constant here, and I'm also subtracting the constant over there. So when I have a definite integral, the C goes away. So let's see. I'm going to end up with 16 minus 7. Anyway, 16 minus 7. So my total area for number 5 would have been 9 units squared.
So where did you get the over 4 when you divided?
Because remember the over 4? Now we had 1/2 times x squared, right? Did I start off with 1/2 over, yeah, 1/2 x, right?
Oh, yeah, alright.
Okay.
Either I'm really dividing the capital or
Okay, don't forget, like, share, and subscribe. Please tell me